Hello all. Today we will be discussing about Diffie-Hellman Key Exchange with an example. Whitfield Diffie and Martin Hellman presented the Diffie-Hellman Key Exchange algorithm in the year 1976. The purpose of the algorithm is to share secret key. Consider the scenario where Alice and Bob are communicating parties and Eve is the attacker who is targeting the secret key that is shared between Alice and Bob. Alice and Bob want to talk to each other securely, but assume that a malicious attacker, Eve, has access to the channel as well. How can we share a secret key without the knowledge of Eve? This is a question to be answered, and it can be solved with the help of the Diffie-Hellman Key Exchange algorithm. This picture shows about the Diffie-Hellman Key Exchange algorithm. There are two communicating parties, Alice, and the another communicating party is Bob. The first step that is done by both of them is they share a prime number q and an integer alpha, such that alpha should be less than q and alpha is a primitive root of q. Soon I will be explaining what is a primitive root. The same step is performed by Bob, that is, the prime number q and alpha will be known by both Alice and Bob, and the prime number and the alpha should be satisfying the conditions alpha less than q and alpha should be a primitive root of q. The second step is Alice generates a private key XA. Here X denotes the private key and A denotes the first letter of the participant, that is Alice. And here we have a condition, the private key should be less than Q. Similarly, Bob, he also generates a private key. Here the private key is denoted as X and B is the first letter of name Bob, and the condition is XB should be less than Q. Once Alice generates a private key, she will calculate a public key using the formula YA is equal to alpha power XA mod Q. Here alpha is already known, XA is the private key that is generated, and Q is also already known. So the public key represented as YA is generated or calculated, and this public key will be shared with Bob. It is shared with Bob here. And on the other side, Bob also calculates his public key using the formula YB is equal to alpha power XB mod Q, and he shares the public key with Alice. So both Alice and Bob has now shared their public keys. Once they know the public keys of the other participating candidates, Alice can calculate the shared secret key. So now the shared secret key is calculated using the formula K is equal to YB, that is the public key of Bob, power XA, that is the private key of Alice, mod Q. And Bob also will calculate the shared secret key with the formula YA, that is the public key of Alice, and XB, the private key of Bob, mod Q. Both the results will be the same. If it is same, then they have successfully shared a secret key between them. This picture was taken from the reference book William Stallings. And what is a primitive number? Because we need to have a primitive root, right? So primitive root of a prime number P is one whose powers modulo P generates all the integers from 1 to P minus 1. Okay. So this can be also represented as, to be a primitive root, a number alpha mod Q should hold a value between 1 to Q minus 1, and alpha square also should hold a value between 1 to Q minus 1 and goes on till alpha power Q minus 1. For example, here I have taken alpha is equal to 3 and Q is equal to 17. So the first value 3 mod, that is alpha mod 17. Q is 17 here. 3 mod 17 will give you 3. 3 square mod 17 will give you 9. 3 power 3 mod 17 will give you 10. It goes on until Q minus 1. Here our Q is equal to 17. So Q minus 1 is equal to 16. Until 3 power 16 we have to make the calculations. And on the right hand side we have got the answers where all the values will be from 1 to Q minus 1. That is 1 to 16. Okay. So if you have all the values from 1 to 16 without any repetitions, then this number is said to be a primitive root. Now we shall see one example for Diffie-Hellman key exchange. First we have Alice and then we have Bob. So Alice shares the value of Q is equal to 23 and value of alpha is equal to 9. And Bob is also having the value of Q is equal to 23 and alpha is equal to 9. Once they have the Q value and alpha value, they have to choose a private key. So the private key is chosen, that is XA is equal to 4 and Bob is choosing a private key, XB is equal to 3. Once the private key is chosen, the public key can be calculated. So the public key is represented as YA, which is equal to alpha power XA mod Q. And when you substitute the values, we will be getting 9 power 4 mod 23, which is equal to 6. So the public key of Alice is equal to 6. Similarly, Bob will be calculating the public key. YB is equal to alpha power XB mod Q. And after substituting the values, the public key answer is equal to 16. So now Alice and Bob have to share the public key with each other. So share YA to Bob, that is done by Alice, and share YB to Alice. Okay. So they share the public key. So they each other knows the public key. And now it is necessary to calculate the secret key. So Alice will be calculating the secret key using the formula YB power XA mod Q, and Bob will be calculating the secret key using the formula K is equal to YA power XB mod Q. And once the values are substituted, here Alice has got the K value is equal to 9 and Bob also has calculated the K value and he has got the answer as 9. So now both of them have the same value and hence the public keys are, the secret keys are generated. So now they can share any message with the help of this secret key. So this is the main advantage of Diffie-Hellman key exchange. Hope you have understood this concept. If you have any doubt, you can share your views in the comments. Thank you.